All right, thanks everyone for joining us and for those that will watch the recording here. My name is Amanda Cotton. I work for the Minnesota Pollution Control Agency, and I help coordinate Minnesota's electronic waste law that passed in 2007. And then I also help with managing our rechargeable battery law that passed in the 1990s. And with that work, the law that passed that we'll talk about today um, and what came with that was brought to me to help work on that. So we'll go through that today.
All right, I'm gonna share screen for
Mhm.
you and get it going. There you go.
Okay. So the next slide, thank you. So the task force, so the Critical Material Recycling and Recovery Task Force passed in 2024 with a report with recommendations due December 2025. There were 15 stakeholders, and you can look at the logos here, including state agencies, solid waste administrators, organized labor mining, environmental justice orgs, energy advocacy orgs, electronic waste recyclers, Minnesota tribal government, manufacturers that use critical materials, and electric utilities. So we hired SDK Strategic Services to facilitate the task force and help write the report. So today we're going to review the findings from the report. And there may be some task force members on today. And if so, we can give some thoughts. They can give some thoughts at the end if they like. Here's a slide with the leadership team. You can see Chris with Ottertail, Dave Benke with PCA, who is since retired, Moaz with Great Plains Institute, and then myself there, and then Stephanie with SDK Strategic Services. So our charge, so the law, and of course, we received that, and then just wanted to break it down into what my brain could see on how to break out what this task force needed to do. So if you look on in the middle, there's a roadmap that we had to get at the end. So if you look at the left side, we started with it says, what are the options to prevent products with critical materials going into the landfill? So the task force was tasked with what's out there to get these captured. And then with that, if you go down the arrow from there, identify needed infrastructure to collect, transport, and recycle critical materials. So we have, kind of something to start with, to look at, electronics, batteries, and so on. But what else is needed to go even further with that? Then if you go to the right side, tasked with investigating emerging technologies employed to recover critical materials. So you get it all collected, you have your infrastructure and so on, but now you need to get it recycled to get the critical materials out to go into new products. And then to do that, consult with stakeholders on recycling and end-of-life management options. So what's out there? All right, you learn what's out there. Now finally evaluate economic, environmental, social costs, benefits, and impacts associated with methods of recovering critical materials. So looking at that whole line that goes along with that process. And next. So what are critical materials? So critical materials is a broader energy focused category. They're identified by the Department of Energy as essential for energy technologies at risk of supply disruption. Think lithium, cobalt, nickel. Then you have critical minerals. They are a federally designated list. They're identified by the Department of Interior as critical to the U.S. economy and supply chain. So think rare earth elements, graphite, tungsten. So in short, critical materials equal energy focused list with the DOE, critical materials official federal list. So another way to look at this, and this is some tables that we brought out while working with the task force that I really like. So this is from the Department of Energy. So the DOE breaks them into critical, near critical, and non-critical based on importance to energy and supply risk. So we started out on the short term on the left side there, and you could see what is in red for critical. And then through our short time together as a task force, just about a year, we already moved into the medium term. So you could see the various materials, minerals on those two graphs. All right, thank you. As we know, critical materials are everywhere. So looking at the first photo there, you can see batteries for grid backup. They're in electric vehicles, scooters, think lithium, nickel, cobalt. And a note here on this, so data centers are comprised of several technologies that each rely on critical materials. So you have your hard drives, your servers, your cooling equipment, your backup batteries, and each have different mineral composition. So taken in total, data centers rely on 23 of the 56 minerals on the critical materials list. Picture two there, you have a medical device, in Minnesota. We have various medical companies here. So titanium, platinum, for example. Then you have some EVs with the batteries being charged. You can look at lithium and cobalt to get out from there. And then you have a wind turbine where you could have magnets made of rare earth elements, for example, and other renewable energy. Minnesota's assets. So Minnesota, as I mentioned, we have a strong foundation with our rechargeable battery and e-waste laws, but the task force identified key areas where we could capture more critical materials, including advanced technology, medical devices, clean energy. So we have this foundation, and the e-waste and the rechargeable batteries, they fall under, it's called product stewardship, where manufacturers help pay for the end of life of the products. So that's one area that we did look at. And in addition, PCA has conducted a stakeholder process and report for collecting and recycling solar panels, and is currently and we just currently worked on e-waste and battery bills for this 2026 legislative session. And then we will discuss now how to go forward for the 2027 legislative session around e-waste, batteries, and solar. So input on that is always welcome. Next slide. And I'll pass it over to Stephanie.
All right, thanks, Amanda. So my name is Stephanie Devitt, and I am principal consultant with SDK Strategic Services. So we had the opportunity to work with Amanda, the leadership team, and the task force on the critical materials recycling and recovery task force, both designing the facilitation and some background research that supported the conversations. And so I'm going to walk through some of those elements with you very quickly. First of all, we wanted to set up some anchoring decisions that the task force made early in our time together, because that really influenced the way we approached our conversations over time, as well as the recommendations that we're sharing with you today. First of all, as Amanda mentioned, critical materials is a broad list. So we're dealing with the DOE list that was referenced in the legislation was 56 different minerals and materials that are quite varied in the products they're in, and a variety of other elements. The task force decided that they wanted to focus their time together setting up a framework for all 56 minerals, rather than going deep in a few minerals or some specific products. At the same time, the task force wanted to make sure our conversations and discussions really focused around setting up a circular economy on critical materials through recycling and recovery. And because of that, we approached the project overall as creating a policy framework at the state level for how Minnesota can think about and approach critical materials recycling over time and across those 56 minerals. And so we used a few things to support the task force. We used policy and literature review. We did a number of stakeholder interviews with experts as well as community members. There were public input meetings held. And then in addition, the SDK team did some primary research into some of the minerals and commodities themselves, just to help inform the conversation. And as we thought about the task force's goal of really looking at all 56 minerals, one thing that we recognized is that each mineral is at a different place in terms of its economic demand on that circularity front, as well as the potential for recycling. And so we spent some time really thinking about and evaluating all 56 minerals against a variety of measures and came up with this overall framework to guide our conversation. So we were thinking about critical materials in terms of scaled minerals, so those where the recycling systems are well developed. And the question at hand is really how do we get more materials and minerals into those systems? Which was different than scaling and emerging classes of critical materials where the technology and the demand for recycling is just starting to hit an accelerated pace. There's also a different cost for many of those minerals where the ROI on recycling can look different. Again, back to that circular economy objective. And those are often minerals where we have even less refining and recycling in the United States. So just tried to acknowledge some of those differences as we were thinking about how to approach all 56 minerals. And then we also spent some time working as a team and thinking about really the full circularity life cycle. So we were fortunate to have on the task force representatives who really do the work of collecting and sorting our traditional solid waste, as well as those who are in the deconstruction work and knowledgeable of things like secondary refining and primary refining. But we did acknowledge in the conversations that a lot of that refinement work, like what happens, for example, Redwood Materials was on our task force and they're working on lithium and battery recycling out of Nevada. But some of that more detailed refining that's happening in minerals like that is not as established in the United States, but an important part of recycling overall. And then in addition, sorry. We spent a little bit of time just looking at the variation in recycling capacities, um, both across products as well as across critical materials. So we recognized that the consumer products are continuing to include critical materials. Think button batteries, greeting cards, e-cigarettes. Amanda shared a lot of stories about um, things she's seen in her work and in other states in terms of the impacts of those materials. But we also found that there's new and emerging technologies for recycling, specifically around critical materials that are more precise, more product and mineral specific. And those new technologies are less impactful on the environment. They can even be positive. But they do also take a greater depth of knowledge of specific products in order to do that recycling work. And so there's some trade-offs that come in some of those emerging technologies. Um, and then we just recognize that there's also new business models that are starting to appear where companies like Apple and Amazon are really thinking about buyback programs and reusing their materials themselves. And so as we get manufacturers thinking about recycling of their own products and their own business models, it led to some additional questions for us about how should we think about Minnesota's approach to this work moving forward, because it is an area that is emerging, but we have the good fortune to be on the front end of these emerging technologies and economies. So, because of those anchoring decisions, the task force really organized its recommendations first around a policy framework. So, at a vision level, really focused on creating conditions where Minnesota can lead the nation in critical materials recovery and recycling, and anchoring that in some core principles: environmental protection, economic vitality, circularity, leadership, and innovation. The task force also uh, really coalesced around three core goals for the future of Minnesota. Number one, reduce, reuse, and recycle first. That's exactly like it sounds and so important. Number two, cultivate implementation readiness. So we recognize that the number of critical materials and products and in the waste streams today is not at all reflective of what it will be in the future. But the task force really wanted to set Minnesota on a course of making sure that it can meet the moment in terms of capturing those materials that are going to continue to enter the waste stream and enter our economy. And then finally, identify criteria for a bet-worthy critical material. So are there one or two critical materials or products where Minnesota could not only be a leader in that recovery of products on the market, but potentially anchor circularity or circular economy opportunities around critical materials? few measures were identified as well. So in terms of use and recovery, the volume of waste with critical materials, the amount of critical materials recovered, and volume of critical materials in the Minnesota economy were points of interest so that we could understand proportionately how Minnesota's doing. Environmental and health impacts in terms of both the recycling facilities as well as the net impact of critical materials recycling. And then finally, the task force wanted to look at the impact of energy in the economy. So thinking about what were some of the energy impacts of disassembling products with critical materials, as well as the recycling costs that might be involved in that. And then we set up a series of recommendations around 4 pillars. The first 3 pillars, reduce and reuse, consumer recycling, and business and industry recycling, are really anchored on this idea that critical materials continue to be and will continue to be in Minnesota's economy and waste stream. And our solid waste management systems need to be designed to really recover and maximize those. And then this 4th pillar is where we focused the conversation around how can we not only recover what materials are out there, but think about recycling from a circularity lens and where can we really make efforts to accelerate critical materials recycling. So Amanda's going to walk us through some of these recommendations.
Thank you. I was going to note real quick for the slide that Stephanie did on the measurement that this
Mhm.
past session in 2026, there was a bill that came through to, based upon what they saw in the report, and we'll keep going through this, but to measure what is coming in, what products are coming in that have critical materials, and then what's going to recycling, what's going to the landfill. So that'll be a huge project, but that did not pass this past session, but we'll see what comes for the future. All right, pillar 1, reduce and reuse. These terms weren't in the law, but it was important to the task force to make sure to point this out. And so for this one, offer benefits such as product development funding, tax incentives, or grants for producers who create products that can be easily repaired and reused. Consider similar incentives for companies that create product alternatives to critical materials. A cool example that came out during our time with the task force was a company called Niron Magnetics, right in St. Cloud here. They invented an iron ore magnet. It does not rely on rare earth materials. So the goal is not simply to replicate existing global supply chains in Minnesota, but to innovate new product designs that are not dependent on critical materials. And then finally, evaluate the implementation of Minnesota's newly enacted right to repair law or opportunities to include additional products that contain critical materials. So that program officially, it started on July 1st, 2024. It's still pretty new, but for example, could bring in agricultural equipment or more products to look at. All right, next slide. Consumer recycling, pillar 2. So the task force noted public education and awareness campaigns, make drop-off easy, create a cost-sharing program that makes it cheap or free for consumers to recycle products containing critical materials, consumer labeling, so people know what to do with their products. At the end, extend task force principles to product stewardship policies. So this might all seem like common sense, especially if you're in this world of recycling, but it helped to have a diverse task force that they all agreed upon it and got in the report. And like we just tried for updating, a battery law and we're able to reference report with what was stated here. So I know from my work with e-waste recycling that Free, for example, will bring a long line of cars out for recycling to get products out of the house. So just for a fun fact, I can't see all of you or, know what you're saying, but in your head, I'll just note that when the e-waste law passed in 2007, Minnesota held the largest U.S. e-waste event for Green Thursday. We had free e-waste event at the Mall of America. So just really quickly in your head, how many semis do you think had to come out to pick up all of the e-waste? Give me a second. So that brought in 1.2 to 1.5 million pounds. They had 86 semi trucks to pick up all of that electronics. So now, of course, they're saying free at the end of life. Somebody has to pay for that. So that's still a discussion of where that comes from. But at the very big piece, when somebody's dropping it off, better chances of getting in if it's convenient and free. All right, next slide. All right, business and industry recycling. So the task force noted looking into and supporting workforce training, make sure there's worker safety and fair wages for these jobs around this, grants and loans for recycling equipment, streamline permitting, but keep the environment in mind, of course, make liability and facility insurance costs deductible. The one I wanted to point out on here was grants and loans for recycling equipment, for an example, in Minnesota here. So the PCA where I work, we're able to give a grant out to a company called Cosmos Recycling. And they have equipment to recycle solar panels right now. So if you had solar panels, you could send them right here in Minnesota and get them recycled. But I just talked to them, and there aren't many coming through because it's not required to be recycled right now. So that's something that this task force talked about. And for any comments on this and going forward, how do we make sure that we get those solar panels in? What is needed, like potential policy, for example, so that that waste stream is coming in. But grants and loans can help start to get that equipment in right in Minnesota. All right, that's it for that one.
Sounds good. All right, I'll take this next one and then a couple other final slides before we open it up for discussion from the group. And as Amanda mentioned, but I want to just reinforce that as well. When the task force talked through each of these recommendations, we really spent the back half of last year working through many of the details, but it was always under the umbrella of those principles that were shared in the beginning. So people really wanting to see the environment as a top priority in all of these approaches, as well as an eagerness for pursuing economic potential. So under that umbrella, a few things came to the top in terms of really looking at how Minnesota can encourage a circular approach to critical materials recycling. The first recommendation was to create a tax package or tax credit package that might encourage major critical materials recycling projects and development. So we looked at a variety of examples from states across the country who have maybe mineral specific or product specific incentives, as well as large manufacturer incentives. And those are detailed in the report, but I think the group really coalesced around this idea of creating a package of incentives that could make it attractive to recycle critical materials in Minnesota and build the facilities to really make Minnesota an anchor for the Midwest in that way. Number two, create a major projects implementation process and tools. So one example of major project that we think about here is we looked at, if folks are familiar with DEMCON, it's an anaerobic digester project that's being developed in the Shakopee area. And that major project was made possible because of a variety of variables, contracts with Ramsey and Washington County to ensure a supply, contracts with Xcel Energy to ensure a customer for the end use of that anaerobic digester. But then also they worked in really close coordination with the PCA and Dave Benke, who was on our leadership committee, and others to make sure that they had the support to navigate the various processes needed to start up a project of that size while also meeting deadlines that might come from external financing and things like that. And so the lesson for the task force that we walked away with was this idea of that type of an approach being really valuable when you're investing in major projects that are really anchored towards circularity. Number three, invest in emerging environmentally friendly recycling technologies. So we found quite a few examples where, as I mentioned earlier, at a high level, the technologies that are being developed to recycle critical materials require more precision, more sophistication than what you might see in some large disassembly processes today, but they're also very good for the environment. And so continuing to invest in that type of research around those recycling processes was an interest to the task force. In addition, there was agreement around reviewing the permitting criteria for primary and secondary refining of critical materials. So the idea here, I'll take the example of Redwood, who was on our task force and talked a lot about their experiences. They're a lithium recycler in Nevada, located next to the Panasonic battery plant. And I think we learned a lot from that case study. One thing they talked about was how when they would get lithium for recycling and break it down into these black mass pellets that could get the lithium closer to being refined into a mineral that could go back into new products. At that point, they currently have to send those materials to Korea or Japan to complete the recycling process and then get that lithium back for manufacturing. So we understand there's trade-offs there in terms of being able to do some of that refinement in Minnesota, compared with the environmental costs of sending it overseas and bringing it back. And that was an area the task force was interested in um, getting some review. And then finally, new tax incentives or deductions for the reuse of recovered materials. So another thing we saw in some of the economic development case studies that we were doing around the country is that um, having that circularity loop in an economy and having those incentives to reuse those materials can be a real boon to helping to develop the circularity projects, where you're starting to see it get some traction. So I mentioned Nevada and what Redwood and Panasonic are doing there. And we also looked at others in Kansas and Oklahoma, a little bit of South Carolina as well. So those were from the task force. In addition, the task force completed its recommendations in October. And then, as our team was writing the report and taking everything that came out of those conversations and distilling them down, there were just a few additional items and details that were coming out in our research that we wanted to give a home to so that it could be a tool for people to consider picking up later if interested. So, just wanted to share those key ideas with you as well. Um, our basic conclusions coming out of the full set of work was that Minnesota has the assets for a circular economy, and Amanda touched on a lot of those earlier. Um, we think that the all materials approach that Minnesota took with this project is also very valuable. And at the same time, achieving circularity is going to require a really focused strategy and sustainable governance around if it's a material set or a product set or something of that nature, just to get the components in place. So because of that, some of the recommendations we had thought about was number one, thinking about what Minnesota can do. We'd recommend some sort of sustainable governance for critical materials. And the idea here is that Amanda and the PCA have been important leaders in this project. Deed also was an important contributor and served on the task force. But we recognize that when we think about circularity and critical materials, it really requires input from a variety of agencies at different points in that circularity value chain in order to maximize those opportunities. And so the idea was, can Minnesota think about a way to ensure that consistent coordination and decision making to really advance circularity? Number two, investigate some high potential industries. So Amanda touched on some of the areas of potential that stood out earlier. Minnesota has great green infrastructure in terms of our electric grid. Are there recycling opportunities there? But there's also a number of industries that rely on critical materials. Going deeper on those industries and really kind of thinking through that circularity value chain was a level of depth that we weren't able to complete in the time that we had. But if Minnesota wants to take steps on circularity, that added step would be a helpful tool. Um, in addition, critical materials recycling incentives, and then suggesting perhaps a state circularity team or office wherever that gets housed within the state. But are there people who can really understand the full complexity of economic development around these circularity ideas and be dedicated to advancing that opportunity? I think one thing I think about, and Amanda touched on this earlier, but really kind of brought us back to this idea is so many of these critical materials are really slated for 300%, 400% growth in demand over the next 10 years or more, or actually, or less. And a lot of the infrastructure to think about how we capture those materials when they come off the market or even as they're being developed when you think about manufacturing scrap, those don't those don't exist yet. And so finding a way to meet that moment will take concerted effort, but seems to be a valuable effort as well. So that was the idea behind those. So with that, I know we wanted to open it up for discussion. First, if there's anyone from the task force who's on the call, we just wanted to open up the opportunity for you to chime in and say anything else you would like to say about the process, the conclusions, or your own ideas. There was a few that were registered, but I can't see them right now. I'm going to stop sharing so I can.
I think we have
I
Chris
see
and Ed.
Chris on here.
And Ed, I think, if they have anything.
Chris, did you want to say anything? No? Okay. I'll see if I can text him too.
Or Ed as well, if he has anything. I think that was the other.
You see Ed? Oh, there he is.
Mhm.
So I've got them both. Oh, Ed is unmuted. Ed, was there anything you wanted to add as well, or Chris?
I didn't have anything to add. I just thought, it's very timely and critical considering the work that we had done too with the solar reuse. It all kind of comes together at the same time. And Minnesota definitely has the potential to lead in this direction, particularly like a company like Niron that is investigated in iron and taconite, the potential for critical materials made from other sources that aren't reliant on third country inputs. I think that's an exciting development.
And Ed is with Deed, and we're actually going to meet in person soon tomorrow with to have more of that discussion because some of the questions which um any of you are able to speak on too is from this presentation, what do you want to see happen out of what was all listed there for recommendations? You're like, that is what Minnesota should try for, or for the different orgs that you are all in, do you see a role for your organization? So, for example, we'll be talking to Deed about that tomorrow.
Okay. So there's two questions I'm seeing in the report, and then Chris just chimed in that his audio isn't working, but
Okay.
didn't have anything to add. So the first question, in your research, did you find examples of other states that have established effective circular economy policies? I think on that one I can respond to what we saw on our team. I think the best overall circular one was the lithium loop framework in Nevada, where they're really intentional about building
Oh,
out.
Luther, we're
I'm sorry.
still
Oops.
on.
Oops, sorry, Ed. You got it.
There you
Go
go.
ahead.
So I think that would be the best example in terms of statewide policies that we've seen. But one thing that was really, I think, unique about this project overall is we found a lot of examples of different material or product or industry specific initiatives that would have policies set up around them. We didn't see as many overall kind of policy frameworks where any state was thinking about how do we build this up in our state overall. So it was much more initiative specific. And when we got into that level of specificity, we did see a few other examples. Yeah.
Mm-hmm.
So hopefully that answers the question, but if there's more, happy to follow up. Is there
I mean,
anything you'd want to add to that one, Amanda?
I mean, yeah, I know we've mentioned even in the advertising for this that this is kind of a first for a state to do a law that we did, doing this report from a state level like this.
Mhm.
But then there are multiple states that have laws around recycling for example, e-waste and batteries and so on. So if you would count that as circular economy in a way there. So there are lots of examples there.
Mhm. Okay.
So,
Amanda, I think this next question is for you, and I don't know if you can see these, so I'll just read them over to you.
yeah, why don't you read it?
It says, how does this report align with PCA's recently released resource management report? Do the recommendations carry over?
Yeah, we did kind of look at each other's reports when we were going through here, but I will have to admit that is something that we need to, now that this one's completed, for example, like we need to sit down and do that. And so just you saying that, that's the kind of what I need to hear to bring back to
Mhm.
our commissioner's office on next step. But you're absolutely right. We need to just look at those reports that were just done and talk about any crossover there. We were making sure that there wasn't anything that was against each other. So we were saying the same thing. So we were making sure for that. But yeah, but thanks for saying that reminder on there. And I'll bring that point back.
Okay. And if anyone wants to speak, I see Lawrence Baker has his hand raised, so I'm assuming you'd like to speak. And once I get through these questions, we'll give you that opportunity. So if others want to share as well. Ramla, I see. I'm curious what you all see in the horizon in terms of more sophisticated extraction methods for these critical minerals. What's the potential of methods like biomimicry? So I can speak to some of the methods that we looked at and just kind of the overall trends. Um, we interviewed the Ames Laboratory in Iowa as one example of some of the places that are really at the forefront of the recycling technology. And we were really impressed with just how sophisticated some of this is getting. I think there's one example that we saw where they can break down platinum almost to the atomic level. Um, One of the challenges they shared about some of those recycling technologies is that very often there's just a cost barrier, especially if you don't have a business partner to ensure that consistent supply. And I think those findings, when we started getting into that sophistication of some of those new technologies, is what led us back to looking at like DEMCON and some of those projects. So setting up that overall circular supply chain seems to be really a key linchpin in getting some of those new technologies um, to be adopted and scaled at a level that it's most helpful. So that was kind of a driver behind that idea. So, um, biomimicry, I'm going to have to be really honest. I have to go back and look because some of that research was done almost a year ago, but I'm happy to follow up with you directly once I double check it, if that's okay. Is there anything you wanted to add to that, Amanda?
Nope, I can't speak on the biomimicry right now,
Yeah, same. All
especially
right.
being recorded.
Nate Blazing, has there
Yeah.
been discussion of lithium battery recycling as a metal recycling company in Minnesota that is a large issue problem for us right now? New legislation relating. Um,
Okay, so for I think Nate, just looking over at the question here. I was trying to think at first if it was getting recycling in Minnesota or more about like a recyclable or rechargeable battery law. So I think it might be more with that.
should we let him speak and clarify?
Sure. I just want to make
Okay.
sure. I think it's maybe around legislation for collecting and recycling batteries.
All right.
I think is going to be my guess.
Nate, would you be willing to just chime in with a little more clarification on your question so we can respond well?
Sure. Are you able to hear me now?
Yep.
Yep, gotcha.
Okay. I wasn't sure if my mic was working. It's basically getting rid of the batteries. We don't accept them, but it seems to be kind of a pinch point for the public to get rid of them. So
Mm-hmm.
we find them in all of our material. We've had fires related to them. I know I've been with this company a year and a half, and I've specifically been working trying to find vendors to get rid of them. And it is difficult and it's very costly. So just knowing the amount of lithium batteries that are showing up in everything right now, that has been one of our huge concerns. So I was just wondering if that was a discussion point of this task force and if there was any conclusions or thoughts going forward. So thank you.
Mm-hmm. Yeah, well, we do have the rechargeable battery law currently in Minnesota that we've had since the 90s, and where the manufacturers have to either ha have their own collection site and take the batteries back in Minnesota or work with a company, which usually most often they work with Call to Recycle, now called the Battery Network. So we have that, but then it's been around for a while. So just this past session, um, we worked with multitude of stakeholders to try and get a new battery law put in that would be for more than just rechargeable, because there's lithium batteries that are also not rechargeable, to get more included. So that did not pass this session, but we're looking at doing that again. So, and Nate, I can talk to you more about that outside of this.
Beautiful. Thank you.
Yep.
Can I ask one follow-up question on that? Because I think it might be helpful kind of writ large for everyone. When I hear lithium battery, I think about it kind of two scales. One is those small, like the button batteries or the battery in your cell phone or something in a consumer level product that oftentimes the battery itself could be small enough to fit in the palm of your hand. And then there's lithium battery recycling, like the charge pack in an electric vehicle or a scooter or some of those things where Redwood really, that's kind of how they got their start, if you will. Is there anything that we should be pointing out to the group about that distinction when you think about some of the things you had said, Amanda, about your answer?
Yeah, it's definitely a distinction and a hot topic when
Mhm.
discussing language and what's going to be included or not. And this is going on across the country. So whether like a medium format, the bigger ones that are above 300 watt hours, whether those would be included or not.
Mhm.
And then all the way up to the EV vehicle battery. And that
Mhm.
seems to be, it's going to be more of its own language all on its own. It's its own world there. So yes, that's a very big distinction. And it's a back and forth of whether it's included or not, and if it will be covered. And then because the various HHWs have to decide what size to take and so on. So yes, it
Mhm.
is a distinction. And we shall, it's still a conversation, but the people
Mhm.
speak up on it, and like what, for example, when Nate's saying what he's seen of the various sizes, and that it's
Mhm.
a hard time figuring out where to take them and the cost, then
Mhm.
let us know.
Yeah. The other thing I think about, just having learned about the topic, kind of coming in and working with you and the team last year, is, what stood out to me from Redwood in that case study next to Panasonic that was so, I think, informative to a lot of our work, is they were able to get their start recycling lithium and lithium batteries because they were next to a manufacturer. So they had that manufacturer grade, both quality of material and scrap, but also volume. And then as they've gotten more of those EV battery packs, now they can take more smaller pieces that are coming out of those consumer products from other folks in the system that were on the task force, like Amanda and Dynamic and some of those.
Mm-hmm.
And so I just point that out in relation to the recommendations because I think when we think about the task force conversations around circularity and kind of the value of building out that critical mass, no pun intended, on some of these specific minerals, I think that was part of how those pieces seem to support each other,
Exactly.
even though they look distinct. So there's someone here, Mickey Pearson, talks about Detroit diesel
Yeah,
remanufacturing and inhibiting, and they
I
do
made a
EV
note.
battery recycling.
I will make a note of that.
Mickey, is there more you want to say about that? Do you want us to just have you jump in? I suppose you can answer that until I allow you to talk. And then I see Lawrence has his hand raised, so I will just, how do I do this? Here we go. Lawrence, I see you've got your hand raised. Was there a question you wanted to share?
Yeah, I have a very broad question. There's one universe, we would take everything that we waste in an urban system and grind it up like an ore and extract things in some sort of an extraction operation parallel to the way we do with natural ores. So you have a copper mine. For those who are unfamiliar, you grind it up into a powder. You separate it based on gravitation and sometimes magnetism and all kinds of other processes, and you get these various streams of copper and platinum and whatever else is in the gold, maybe mixed in with the copper. And that's an exhaustive process. But if we go to, and in various ores are processed somewhat differently, but they're basically grinding a lot of material to get a little bit of product. But in the urban setting, the question I would have is, how many, if we want to go to complete recycling or nearly complete recycling, or as much recycling as could possibly be economically valuable, has anybody looked at what sorts of input streams we'd want to have to the primary processing of that material? I mean, how at some point we're sort of smeltering or separating into pure material, but that's coming from a lot of sources. Has anybody tried to maybe optimize or even think about how many waste streams we would end up with to make it feasible to extract those metals, either economically or determine which ones would not be economical? That's I know that's a somewhat ambiguous question, but I'm hoping you can interpret that a little bit.
I'm trying to think if we ran across anything like that to that level.
I mean, in theory, just I was glancing around through some literature, and there's as much copper in buildings in percentage of weight as there is in copper ore. So theoretically, you could grind up buildings. I mean, when they're done, of course, and get copper ore out of it. But that would be an expensive way to do it. It'd be better to take the copper out first and then just process that as almost pure material, which is what we do essentially now. But it's possible you could do it. But other things like electronics, there may be enough material there to just throw all the electronics of all types into one bin, grind it up, as to do with say a primary ore, and extract it in many different elements or metals, 10, 20 different metals that each go into then different streams for final processing into ignits or whatever. And the rest just becomes waste. But has anybody done that? I mean, even on paper, I realize we're nowhere near actually doing that.
I can share a bit about some of what we did trying to get at pieces of that. I shared earlier that recycling feasibility framework, and that in a way kind of started from a similar idea of what you're talking about. So the overall net idea that you're talking about in terms of putting all electronics in a pile and how mechanically can you shred and separate those. We didn't look at that per se, but we did look at how do we start to make decisions about which critical materials to prioritize or where it makes sense to recycle the most, and then what are some of the barriers in terms of how products are constructed that might make recycling harder. And the answers we found to those two questions, I would say first on the critical materials recycling, that feasibility framework that we looked at, we specifically looked at what's the current state of the recycling technology for the mineral? Like, is there a process in place or technology in place to get something that's been used back into a usable or pure enough to be usable form? And then what is the price per ounce of that mineral, and what is the projected future demand for that mineral? Because we thought that would start to give us some way of thinking about where do you prioritize time, or where do you prioritize investment. In addition, one consistent thing that we've seen in the minerals where recycling has the greatest both opportunity but also success is that very often the recycling facility that really gets things going is very close to a manufacturing or industrial grade supply. So we mentioned critical materials, the lithium being next to redwood, or redwood and Panasonic being next to each other. But you also see in Oklahoma, the recycling that's taking off there is more the materials that are used in manufacturing NASA products. SpaceX is in Texas. So that's kind of where they're getting their supply. Some of the recycling that's taking off, like in South Carolina, is near the auto manufacturing plants, and they're grabbing some of the rare earths and some of the lithium coming out of some of those. Same with Michigan. So where you're seeing pockets of things really get some traction, it's because the recycler is close to a manufacturer that has both the volume and the purity in their just natural scrap of business, that it gives you enough of a volume, you can start to bring in the critical materials from other places and sources
Hmm.
and recycle that way. So that's where we found that loop working well. I feel like there's one other question you had. Oh, the one other thing about how products are constructed. I know if Amanda from Dynamic was on here, we'd probably have
Mm-hmm.
her say a little bit about this because she brought it up quite a few times. But very often, one of the challenges in critical materials recycling is the materials themselves are being deconstructed or used at such a small level. Sometimes it's just almost like sheets of paper. And so the size of those minerals and the amount of glue that can be on those minerals can be kind of a barrier to deconstructing and reusing those. And that's back to where some of that ROI comes in. So she referenced, I don't know, Amanda Cotton, if you remember the conversation with her where she was talking about like the screens on refrigerators and like how many minerals can show up in one of those. That's where it gets really hard to recapture and reuse some of those minerals because they get broken down so small and they're compressed so much that the ROI on the reuse gets harder. So, not a direct answer, but those are some of the things we looked at, trying to at least get some footing to that end.
Okay. Yeah.
But a good question to bring back because what are next steps? And one of
Yeah,
them is data.
absolutely.
So I do see the questions now.
Okay, go ahead.
Or just are we looking to see if some of the recycling activities could be displacing pollution or causing new environmental problems? So that was in the law to look at that side of it, not just to just do any recycling, but what is yeah, what would happen with the air and so on. Or there's chemicals that are used in the process too. So then what are you going to do with those chemicals? So we did have to look at that as well. Um, I don't know how deep, I'm trying to remember how deep we got into that on specific processes, but I know you did this slide on um, that we looked into various types of recycling, but I don't think we had specific ones and whether they would cause more pollution or not, but we would need to, any company coming into Minnesota would have to go work with the PCA and others on looking at that.
Yeah, and there's a graph of comparison in the report on what we did look at. So there was just a few methods we compared where there are some that are, so like liquid or water splitting, some of those types of
Hmm.
methods are more environmentally friendly. In general, like a lot of the methods that we did look at, we know the processes and the technology is changing daily. But a lot of them were more environmentally friendly, but they required more direct product knowledge in order to be environmentally friendly. So you have to understand what you're trying to break apart and why. So there are some, I think, economic challenges in that when you think about creating a recycling system, because very often manufacturers don't want to tell you their exact manufacturing processes so that you know how to take it apart. I think that's why you see some of those companies like Apple or Amazon bringing their recycling in-house. The other thing to be wary of or just cognizant of there that we paid attention to is that a lot of these products, the engineering of the product itself is changing at an incredibly fast rate. So you can't always like build a new system to deconstruct something that will change, like what Niron Magnetics has done with the iron ore. And then the other thing that we talked about a little bit was just this idea of the secondary and primary refining. So there's environmental challenges in that refining, getting any mineral back to a reusable state, whether that happens in the United States or a foreign country. And then there's also the transportation impact and costs of getting a mineral overseas and getting it back. And there's trade-offs on doing that locally. So that piece where we left it in the recommendations was more to investigate some of those criteria around permitting to really do that trade-off, but not directly answer that question. Does that help?
Mm-hmm. Yeah, thank you for good job remembering that part of the report. And a lot
Sure.
in there for us to remember. Um, let's see. Oh, what should philanthropic orgs be paying attention to in terms of who is doing this work? Is it reasonable to assume that social business, private sector orgs, and government agencies are doing this work, or are nonprofits playing a significant role? Well, I think they could for sure, but the Blue Green Alliance is the one who created this, started the thought for this law in the first place and where we are at with this. So I definitely think they can play a role in speaking up. And I mean, just in my world, like I've talked about the various bills that we're working on that are there for many reasons, but one is to bring more material in and get the critical materials. So to have support
Mhm.
on those is always helpful. I don't know if you have other thoughts there.
No, I think it's a fantastic question. And to be honest, I hadn't thought of it till now, but that's a great one.
Mm-hmm, mm-hmm.
I know there's a lot of philanthropic organizations invested in like future economy, climate change, anytime we're thinking systems change, um, really thinking all the way through in terms of the life cycle of the new can always be valuable, right?
Mm-hmm.
So I
I
see
don't know.
Chris has something
Mm-hmm.
in here.
It's probably for us to read. Could everyone see this or just us?
I'm not sure. Maybe it's worth just reading out to make sure everyone hears what
Sure.
Chris says. Mhm.
Chris was on the task force with us. So regarding grinding up stuff and treating it like ore, our waste to energy facility is currently communicating with a company from Europe that is mining critical materials out of incinerator ash. We, which is Prairie Lakes Municipal Solid Waste Authority, recently received about an 8.4 million in funding to build a facility to do similar work. Outside of this specific application, I think is a big grinder is cost prohibitive. It's something to think about, yeah. Hmm. I know we just have a minute here, but thanks for all the questions. And if you think of anything to you can email myself or Stephanie because I know I'll for sure be bringing this to the commissioner's office and like, what are people saying about, hey, PCA, this should be a next step, or these organizations should be working together, or we need somebody in Minnesota to focus on this, and who should it be and what. So we can take any of those thoughts after too.
Great. Any other final questions? Otherwise, I have to say thanks everybody for taking the time and for being so thoughtful. We'll be giving the same presentation next Thursday, and we have recorded this, so I think the intent is to share it with those who are interested. So thanks for your interest in the work.
Thank you.
All right.
Bye-bye.
Have a great day all.